I welcome you to this YouTube channel. Which is Mwalimu Education Services. So today we are going to look at nuclear processes, a chapter which is in Book 4 of the new competency-based curriculum of chemistry. I don't know how you are going to handle this, but I recommend that you first pause, then you listen. No, you don't pause, as in you do one thing at a time. You can decide to first listen to what I'm going to present. Then after listening, you pause and then write down the notes. Or, and I think that is better, you first listen, then after listening, you pause and you note down the things that I've presented. I think that will be better. However, also someone can also decide to listen while writing. That is up to you. So today we are looking at nuclear processes, and this is the outline which I'm going to follow in my presentation. So we are going to look at introduction to nuclear chemistry, structure of an atom, which was explored when we were covering the concept of the periodic table. We shall look at nuclear reactions, things to do with nuclear fission and nuclear fusion process. Then we shall look at radioactivity, which is also known as radioactive decay, and the radiations that are produced. These are the nuclear reactions that we shall explore, that is fission and fusion process. Then we shall look at half-life and the related calculations on half-life plus real-life applications of nuclear processes. So nuclear processes, this chapter is under, if I recall very well, this is element of construct. It must be element of construct on application of chemistry in daily life. Yeah, application of chemistry in daily life. Always item 1, however, it can be swapped and it comes as item 2, but it is on the element of construct, which is on application of chemistry in daily life. And for that element of construct, if you recall, we can have an item coming from soaps and detergents, chemicals for consumers, among other things. So now we explore introduction to nuclear chemistry. Nuclear chemistry, basically here we look at chemical processes that result in production of nuclear energy. And the keywords that we are going to encounter, we shall see chain reactions, the reactions that accompany production of nuclear energy can occur as chain reactions. Things for a chain reaction, it implies that it occurs in a chain. We can have disintegration of an atom into another atom. Then that atom that has been formed can also disintegrate further. So to come up with what we call a chain reaction. Then we have emission, fission. Here we look at fission. We basically look at splitting of a nucleus of an atom. Then fusion, this simply implies combining things, combining nuclei of atoms to come up with one atom. Half-life, the time taken for a substance to decay to half of its original mass. Isotope, we covered isotopes. Those are atoms of the same element with the same atomic number but different mass number. Then nuclear decay, the radiations that are produced, and radioactivity. Those are some of the keywords that we are going to encounter. So I start by giving some few basic definitions that we are going to encounter. Nuclear chemistry is the study of chemical and physical properties of elements that are influenced by changes in the structure of the atomic nucleus. So we have the influence of those changes. For example, the nucleus of an atom can decay, and we can have change in its atomic number. However, the process of it decaying and changing its atomic number and sometimes mass number, there are some chemical processes that can be accompanied. We can have emission of radiations, emission of nuclear energy, among others. So the atomic nucleus is composed of protons and neutrons, as we discussed earlier in, I think it was in senior 2, the concept of the periodic table. Those are the things that we looked at. Then the number of protons gives the atomic number of an element, and the sum of protons and neutrons gives the atomic mass. I give an example. For example, if we consider the symbolic representation of the atom of sodium, it has 23 as the atomic mass and 11 as the atomic number. So basically, sodium has atomic number 11, and atomic number is the number of protons in the nucleus of an atom. So since it is 11, we also have 11 protons. Furthermore, the sodium atom has atomic mass 23, and the atomic mass is the sum of protons and neutrons in the nucleus of the atom of sodium. Therefore, atomic mass equals protons plus neutrons. And for sodium, atomic mass is 23, number of protons is 11, then plus n, which represents number of neutrons. So collecting like terms, making n the subject, you have 23 minus 11, so that we obtain 12 neutrons. So the atom of sodium has 11 protons, and also it has 12 neutrons, and the protons represent the atomic number. Then the sum of neutrons and protons, that represents the atomic mass. Next, we look at the structure of an atom. We looked at the structure of an atom during the exploration of the concept of the periodic table. An atom is made up of 3 subatomic particles, which I am abbreviating as pens. P represents protons, E represents electrons, and N represents neutrons. So the protons and neutrons are located in the nucleus of the atom. However, the electrons revolve around electron shells. So these things that you are seeing in blue, these are what we call the electron shells. Then the protons and neutrons are the ones that are centralized in the center of the atom, particularly in the nucleus. Next, we explore nuclear reactions. But before we look at nuclear reactions, there is an activity which I must upload here. And allow me first pause as of now, and I upload that activity. You must do that activity. The activity is on Introduction to Nuclear Chemistry. So kindly copy down these questions, which I am going to display, and we shall not go through them. However, I'll demand their solutions. Take note of that. I'll demand their solutions. So as of now, let me first pause and I share that activity.